Good morning. Yeah, I think we are going to start. Today we have Nambalirwa, who's going to talk to us about work. She's doing a PhD in space physics, and she's our former student. So she'll be talking to us about her work and maybe any other things that could be relevant to us, either as researchers or as students. So please feel free to take us a background when we are here and what we did. Yeah, so thank you.
Description of these cases in case you didn't These are the sprites. They are red in color and mainly occur in these ones are the sprites. They mainly occur in they are categorized into negative sprite and positive. So these negative sprites, they are the ones that occur with negative cloud to ground lightning, and the positive sprites mostly occur with positive cloud to ground lightning. So the negative sprites, they occur with convective storms, and then the positive sprites mostly occur in stratiform kinds of storms, which are not so strong. So this is my research, the problem statement. Africa, especially Central Africa and the Lake Victoria region, experiences frequent intense convective storms, which may generate transient luminous events that have largely remained unrecorded and explored. And then these are my main objectives for my study: to provide a detailed study of the transient luminous events in Africa and they are producing thunderstorms using space-borne datasets and ground-based observations. And these are the two sub-objectives. The first one is to carry out a space-based observation of the transient luminous events and their related storms in Western and Central Africa. And the second one is to carry out a ground-based observation in the Lake Victoria region. Over Lake Victoria. Yeah, so this is mainly about Lake Victoria. I think everyone knows Lake Victoria because we share a part of it in Uganda. And it's Africa's biggest, largest lake and the second freshwater lake. And it creates violent thunderstorms, especially during the night time. Even when you ask the fishermen, they will tell you the same thing. And the climate over this region is influenced by the diurnal cycle and the seasonal cycle. So the diurnal cycle is influenced by the lake breeze and the land breeze. And this is how, this is our region of interest over the lake region. And this is how, every day, the lake produces its lightning or its thunderstorms, according to other people's study. So, most times, elevated heating occurs in the eastern region, which is around here, the Kenyan highlands, from here, Kenyan highlands during the day, and it causes lake breeze. And then, I don't know if you know lake breeze, there's a lot of heating on the surface. During the day, the water is during the day on the lake region, the land is cool and the water. The land is hot and the water is cool. And during the night, it's the opposite side. The water is hot and the land gets cool. So during the day, there is elevated heating from these mountain regions of Kenyan highlands, and it causes lake breeze. So the solar heating and the associated lake and valley breezes, they lead to afternoon maximum convection over the land with peak lightning around this time, around 1 to 13 to 16 local time, which causes precipitation over the land. And then at night, there is land breeze, which is developed by, again, the mountain breezes, the breezes that come from the mountain. And at night, there is deep convective over the northeastern region, and which shifts to this side of the lake, like this region. seasons of March to May and September to November. And March to May is known as the long rains, and September to November are the short rains. And according to different studies, they observe that the mean lightning density of March to May is around 212, and for September to November is around 215 flashes kilometers squared per year. So this region really, it receives a lot of lightning in a full year. And then the Lake Victoria region experiences less precipitation during the seasons. This is mainly known as the dry season, December to February and July to August. Then in July to August, the ITCC, since the ITCC shifts from the migrates northwards away from the region, that's why it causes less rainfall during this time, July to August. Then part 2, I'm going to show you some of my research plan for my work. So the first part I'm going to show you the space-borne observations, and then I'll show you how I'll do the ground-based observation. So this is mainly about the transient luminous events. So we use an instrument, it's called issue. I'll show it to you later. But according to other researchers, they observed from this chart, this diagram, they observed very many sprites, especially in the Central African region, which is around here. And they also observed very many halos, blue jets, and the gigantic jets. So for us, we got the motivation from these people's observation to come and say, like, this region of Central Africa has so much of that TLE, but it seems no one has come out to write about them. And yet, it's more like compared to other regions, it has the most TLEs in this region. So from our research, we got the data from these people. And then we tried to find out how many sprites are in Central Africa, how many blue jets are in Central Africa, how many gigantic jets. But for this, my research is mainly concentrate on the sprites and the blue jets. So in this using issue, we observed 305 sprites in Central Africa and 392 sprites, which is here, in West Africa. And then we still use the same data to observe 485 blue jets in Central African region and 123 blue jets in the West African region. So this was what I did at Masters. I wanted to give you like a recap on how I've been doing this work. This was my work at Master's degree. I retrieved the blue jets from these instruments. Then I compared the blue jets which were in this region with those ones that passed through the trim. Trim is an instrument. I'll show you later. It's an instrument for storms, like for observing storms. It's like a space-based satellite for observing storms. And then I analyzed their meteorological conditions of the storms, and then I found the tropopause height. And I did the same thing for the gigantic jets. And this is my work at the PhD. Since it's bigger, it's concentrated in Africa. The other one was mainly on Central African region. So this one I'll do space-based observation and ground-based observation. And for space-based observation, I'll concentrate mostly on the blue jets and the sprites. And for blue jets, I've done it for Central Africa previously. height. And then here, for sprites, we use other people's work to compare, to sort out the negative and positive sprite. Use other people's model to sort out the negative and positive sprite. Then after, we find the issue data and analyze the meteorological and analyze the vertical profile of the wind. This one I've not yet done. Then for brand-based observation, I'll do the collaboration to get radar data with Entebbe Airport, then learn how to set up the instruments, prepare, then I'll come to Uganda to do ground-based observation and analyze the data in case I find any. Yeah, so these are the data sets I was telling you about. So this is the issue instrument. It's already like, it's no longer there, but it was used to observe the transient luminous events. And then since I also use the MSG data sets, which is used to observe the cloud top heights, and the trim is used to observe the cloud top height, and also it gives a three-dimensional structure of the storm. And sometimes it also has data for brightness temperature, cloud top brightness temperature. And also use these other data sets for observing the geostationary data sets for the cloud top brightness temperature. And this one is for Cape, Wulun. I use Wulun for lightning, and this is for tropical signs. So these are the ones I use for ground-based observation. I use this camera. It's a high-sensitive low-light camera. It's mainly observed during the night. So our observations are done during the night. And then this is the GPS. This is the video text. It converts information from the camera to the computer, so it helps. Then this is like the setup. This was a setup that we did in Guangzhou when I was trying to learn. So I'll show you some of my results. So these are the results I got at Masters. These are like issue data sets. All the issue data sets that I observed for this region of Central Africa. And we observed very many cases, 485. But for our study, when we matched with TRIM data sets, we got 76 blue jets, which are the ones in red color. And for this observation, we only took the 15, which were within this TRIM spatial window. And again, we limited back to 2 cases. And these are the only ones when TRIM passed through. Because TRIM is a polar satellite, it moves. So when it finds maybe this blue jet within this region, we can observe the storms in this region. So at the time when TRIM observed in this region, it's when we found like only 2 cases, which are this one and this one. And so these cases were, this was their cloud top height in the Central African region. The maximum was 16 kilometers. And these were the cloud top brightness temperature, and this was their Cape. So these are the blue jets. This is issue data sets, how it observes. So when it's observing the blue jets, it's just a dot on the satellite. It's just a dot. So this is how it's observed in the imager. And this is the spectrophotometer. And this is the AP, which is the other photometer. And this is how the cases, the study cases that I talked about, the 2 study cases, looked like. So here, the blue jet occurred in deep, very deep convective storms, and this was for cloud top brightness temperature, and this is the minimum temperature. So So it occurred in very cold cloud tops and with very high cloud top heights. This is for cloud top heights, and this is the maximum. And this is stream data sets, and this is cloud top TMI data sets. It's cloud top brightness temperature again, because we needed to compare and see if it was true with this one. And this is still cloud top brightness temperature at 85 gigahertz, and it's still occurred in very high lightning intensity here. And this is from TRIM. This was the rain rate and rain reflectivity. And this is how the 3D looks like the storm structure. So from the storm structure, we can see how high the cloud was. And it's the same with this, but this one occurred in, this is the region of the where I would cut. So we cut here and then observed its 3D, like its height, vertical profile. And then still here, we also observed the vertical profile from this region. So we can see that you can see that the bridges in the Central African region occurred in very high cloud top heights and with very high reflectivity, because this is reflectivity, generally reflectivity. So these were the gigantic jets, but we didn't observe any case within the TRIM satellite. Since TRIM is a polar satellite, it didn't pass through any of our cases. So we only used these two, the one for geostationary data sets. This is the cloud top brightness temperature, and this is the cloud top height. And this is how the gigantic jet looks like. This one here is a gigantic jet. This is a sprite. So we needed to put the sprite so that we can explain this other curve, this other signal that was developed. So this is our case of the gigantic jet, which is here. So since they are very rare, in the Central African region, we only observed 5 cases. And that means that this region is very competitive. Because other regions, they only observe like 1 or none. So when we go to the sprites are very many. Observed so many cases, which are like 305 sprites in Central African region. And using this model, we're able to sort the positive and the negative sprites. So these are the sprites that were observed. All these are sprites. And then the red ones are the negative sprites. And the positive sprites, we just sort a few, since there were very many. For positive sprites, we had 288. And for negative sprites, we had only 17 cases. Yeah, so these are the negative sprites. And negative sprites are very, very rare. But it was so surprising to find that in Central Africa we can get over 17 cases, which is very, it creates questioning of how competitive this region is. Because negative sprites mainly occur in region with very deep convective storms. And this is how they look like. These are the negative sprites, how they look like in the issue instruments. And this is the storm condition of the negative sprites. And they occur in very convective storms with very low brightness temperature, according to this one here. And and then very high cloud top heights, as you can see here. High cloud top heights here and very low brightness temperature. And then you can see here that they still occur, because here we did observe it within the scan. So we found a way to find, when we found a scan here, we're like, maybe, according to this, you can see that maybe it occurred here. So we observed the region near it. And from this structure, you can see that these negative sprites also occur in very convective storms with very high cloud tops. And these cloud tops, sometimes they penetrate the tropopause layer. Because the tropopause layer is mainly around like 17 kilometers. And this is another case, because we are doing case study. This is another case. So these are for positive sprites. Positive sprites, for them, they occur in storms which are weak storms, stratiform kind of storms. And you can see from this, they have very very high brightness temperature. And then you can see from this one, their cloud top height is not so high. And even from this region, you can see that in the region they occurred, their height is not so. The region has less reflectivity and less what? Very low height. So they occur in this not so strong. The ones that you can see, like which cause very not so strong rain. They cause, I don't know how to explain, but the rain is not so strong. So this is another case for positive sprite. And here we can see, because volume is mainly used to observe cloud to ground lightning. So you can see that this the positive sprite, where it occurred, you can see so much lightning here. Because volume is mainly observed the cloud to ground lightning. So I'll show you my study schedule in case other people, in case I come to do ground-based observation, maybe some people might be interested to join me and do some observation. And we'll also learn how to do this observation by ourselves. Yeah, so this is my plan. By Feb, contact these people from the airport to find data for Doppler radar data sets. I want to first study the storms, like using this Doppler radar data set, and then March to June I want to complete the space-based observation and also try out some instrumental setup, which I'll use for my observation.
say to the sky, what exactly are you?
I'm going to observe the same TLE, these transluminous effects. These ones, but then these ones, I'll be observing them from ground using the camera.
So this is a specialized camera, it's not these ordinary cameras.
Yes, because like the camera can observe, like for these cases, because I think detailed, the blue jets and the gigantic jets, they observe them from around 300 kilometers away from the region of interest. So we may be in northern Uganda, something like that. 300 kilometers from the region. Because these ones, they occur, because if these are the clouds, they occur just above here. So when you're observing, then you have to be so far from the region of interest.
So if you are interested around for, let's say, the Lake Victoria, then you either have to go to the northern part of the
Yes, northern part. And you observe from there, but then you have to point, because I didn't put an illustration, you have to point like or above the convective storm. You have to know the place of the convective storm. Like the latitude or the place of the convective storm. Like if this is the convective storm, you point it here, around here. So it observes the whole night automatically. Yes.
Thank you.
Then we can also observe like for the positive sprites, you can observe them, and the negative one, you can observe them even near, like maybe here, if you want to observe Lake Victoria, because for them they occur very far, like they are high.
Yes, okay. I think we can have questions, more questions for Alice. Yes.
So thanks, Alice, for your presentation. A few things here and there. So what is deep convection?
Oh, deep convection. Deep convective storms. These ones which, like in normal times, they are the ones which have occur here, like around this region. They have so much wind. They have lightning in them. Then, like they are so strong. I don't know. These storms which you can find 90%, the tree broke. The trees broke, the iron sheets were taken. They are so strong, they have a lot of wind in them. I don't know if you understand.
What would the alternative be if it was not a deep convective storm?
It's a stratiform storms. Stratiform storms. These ones which just, like, they are like showers. I think they're the ones that are occurring like in January. Like this season. The rain, like it forms a cloud, but the cloud is not so big. It's not black. If you can see from the sky, the cloud is there, but it's not so big. It's not black. It's very small. So it showers and stops after some short time. But for deep convective, it becomes cloudy. The place becomes like black, very dark, and then it rains for like maybe 3 to 4 hours. That's strong rainfall. I think these ones mainly occur maybe in April. You can see such storms, and maybe April, May, and also in November. The kind of rain that we had like in November that is very, very strong. Hopefully you understand.
Yeah, but a few things here and there. Again, you had a slide with the such significance. I think it is that one, where you mentioned that the long rains are between September and November. Are you speaking in Ugandan sense or Kenyan sense?
The Uganda.
For us, our long rains are the ones that actually occur September to November, and then the short rains I don't know, unless I'm getting it wrong, but I've been around Uganda for a very, very long time. Our long rains are September to November, and then the short ones are the other way around.
Now this one is according to documented information. Like for articles, they show that the long rains are in March to May, and the short rains are in September to November.
Yeah, I think TDS will go past in this one. For me, from the years I have lived, it's the other way around. And the problem with that, now that inversion is, it coincides with the fact that you say there is a lot of heating around the Kenyan Highlands. I think that is also not really, according to what we know. The Kenyan Highlands in East Africa are some of the known very cold regions. This you can put in AIN1, a quick research will show Kenyan Highlands are a very cold place. The temperatures there are low. The beach are growing apples there. That's how strong it is. So I don't know why all of a sudden the temperatures are highest there, that they are driving the breezes. Contrary to what I would have really fathomed. I don't know, again, other colleagues might be saying something different, but for me, I don't know, maybe I haven't really read about Kenya, but it might be so that the Kenyan Highlands are actually very cold. And then one last one, sir, UNMA, the arrangement that no longer exists.
Oh, yeah.
And the last time I went there, they did have data sets dated to Doppler. Yeah.
I went there and they have.
Yeah, that is very interesting. So maybe the collaboration will go, but we went there with Dr. Serionga, and the information we got was contrary to what he said, but maybe if you have already talked to him, probably.
Okay, for this one, we are talking about like for in a day. This is like how like a day in a storm, like a life of a storm, a lifetime of a storm, like in a one day. I don't know how to explain. This is like for one day. Explanation of how a storm forms from around the Lake Victoria region. In case of a storm day. You understand? Like for a storm day, the Kenyan Highlands in the morning, they have these breezes that come from the highlands. Like when the sun shines on them, they bring like if sun shines on a mountain, it has, you can see like some kind of breeze. So that's the kind of breeze that we are talking about. That hits the highlands, and then the highlands hit up the whole, because these are like mainly highland areas around this region. So if the highland hits up, then it gets the breezes. Then these breezes are the ones that form rainfall over this region.
So Alice,
yes.
What is the total distance? Maybe an approximation between the nearest point from Lake Victoria to the Kenyan Islands compared to what the nearest point of Lake Victoria to Mount Renzo. For me, the Renzo Mountains are near. They are nearer to this.
Yes, they are nearer, but according to other studies that they have done, they saw that it's the Kenyan Highlands that contribute to the rainfall of Lake Victoria, not the Renzori Mountain.
Is that one is also straight? I did some little that come back, and it was the other way around. Yeah.
So this
Maybe we shall talk, but it is the other way around. It was said that the Luzon Mountain actually was, let's say, Victoria, not the Kenyan Islands. And one of the justification was the distance.
because according to what I read, because I was interested into thunderstorms and lightning formation in the Lake Victorian region, they said it's these rains at night during this site. And the storms at night are mainly formed in the Ugandan region. Here, in the Ugandan region, it's that gets a lot of storms and lightning over the Lake Victorian region than the Kenyan side. Because during that day, this Kenyan side is convective. And then, during the night, it's the Ugandan side that is most convective. So maybe, what I saw mainly from this, maybe in Uganda we should also concentrate more on studying our regions. Because that's what I've seen in China. They study their regions. You can't even, when you mention a small region like this, they already studied it. They know it. You can't lie to them about their regions. When you mention that this region, they'll tell you this. If you say maybe Guangzhou, there is maybe winter, they'll say no. According to this study, we've already done it. Here we've already done it. And this is a region of Africa. There's a lot of research that is, people want to come and do. Like people are interested when someone, because like when I was studying at Masters, I was like the only foreigner in the Chinese class. And they used to teach them, like, to tell them maybe we should go and get more research from Africa. It's a burden place. No one has research there. Yes, so maybe in your study here, you people should, if you're picking topics, Africa is a hot cake. Even Uganda here is a hot cake.
Okay,
It's
thank
a
you.
hot cake region. Like, if you do research in Uganda, even someone in US, UK will be like, this person, she knows Africa, you know, like, she has done research in Africa. Because everyone wants to come here and do research. But when they are there, they don't know how to come. They are just, they have some kind of, they are yes.
Yes, thank you, Alice. There is a question from BFD.
Thank you, Alice, for the presentation. I will start by giving a hint why the rain from the east is more prevalent than the one from the west. Because we spin, the earth spins towards the east. So if you see clouds on the east, on the west, that rain will not reach here. This is our west. If it is cloud this way, you never get rain here. It cannot be cloudy and result into much rain this side. It's the one from the east that rains. But my question is, have you interested yourself if there is an occurrence of a CME or any other, if the sun gushes out stuff, does it correlate or does it contribute to lightning occurrence? Have you tried to figure out if there was an event on the sun, like a coronal mass ejection, would that contribute to a more prevalence of lightning thunderstorms?
I'm still on this one for the lower atmosphere.
I think it is easy. You could easily look at the KP index on the website and see whether, if you look at the occurrences of lightning, are correlating with the events, the CME events, especially in our equatorial region.
Because I have a friend who was doing solar research in solar, and also another one who was doing research in earthquake, and they are telling me that if the region that you're saying is very convective, is also in solar is the one with the high
Yes, thank you. We have TJS.
Thank you, Chair, and thank you for the presentation. I'm sure I came too late, so I don't know whether we discussed this. And you know, we are concluding that we have rains during these times based on a given location. For us, my business is around Lake Victoria, which we term as around Kampala, Lake Victoria, but for you, your coverage will be a bit bigger than you are looking at the whole lake. What are the pixel size of the satellite sensors you're using? You know, yeah, because it might be, some of them like 10 by 10 square kilometer, others maybe 5 by 5, but it can rain around the building. Other parts don't have rain.
Because me, I'm interested mostly over
Okay.
the lake.
So you need to investigate maybe the size of the pixels.
But for the lake Victoria, I'm not doing the space-based observation. The space-based observation is mainly for Central Africa. Yes. Because Lake Victoria is a bit, it's also included in the Central Africa.
Yeah.
Yes.
You talked of using machine learning
Yes.
for, was it one of the objectives?
And-
Is that you going to use?
Other people have used it.
So which tools are you going to exactly deploy?
Yeah. For my work, for my research, for these ones here, I use coding like
Which software?
MATLAB.
Okay.
For these ones, I only use MATLAB. I retrieve data sets from the satellite and then I analyze the data sets. But then for machine learning, it was used by someone else to sort, like to differentiate the sprites. Because the sprites are positive and negative sprites. So we are using his work to sort our sprites into negative and positive.
The first one is products. You do share your products, so you are looking at. So you make sure you leave them behind. Maybe you will coordinate.
Yes. Yes. And also we have this collaboration. I don't know who is interested. Yes, you're interested. This one here, they want to set up some instruments. I have like a memorandum of understanding. Maybe I'll send it and people can read through it. They want to set up some instruments to observe the weather here and also the vertical coupling of the atmosphere in this region. Yes.
Yes, otherwise, thank you very much. Alice, like TJS has commented, certainly would be interested in maybe further discussions beyond this to discuss possible opportunities and collaborations with the department. So hopefully you can share with us your contact so that we can always keep
Yes, excuse me, before you leave. How did you manage to go there? Mind sharing their scholarships, connections? These younger staff might be interested. So.
Yeah, I went through like a long journey. I think I came here when I was studying Chinese and people thought I was kind of mad.
Yeah, but I'm sharing them.
So when I finished bachelor's degree, here, I think we finished in May, then I started around July to study Chinese language here at Confucius Institute. So this Confucius Institute, they have their school in China. It's connected to another university in China. And when we were there, we studied short course for a period of time. And when you finish the short course, they keep announcing that there are these opportunities for going to China. If you have like HSK HSK3 written paper. And they helped us to apply for language for 1 year in China from 2019 to 2020. That's when we went. And we studied for 1 year. And then I applied in this university, University of Science and Technology of China. I applied for master's degree. But my grades were not even so good by now. They were not good. I had second class lower. And the person who was interested in doing, my supervisor, wanted to do research with African students from Uganda. So I was the only one who had applied at that time. So it's like, let's take this one. Do you want the research? Do you want it? You know, like me, I didn't even know the things here. I knew nothing. And that's how like I got the opportunity and went to study there. And when I finished masters, most times they want you to maybe do PhD. So I was like, I have nothing to do, not so much to do. So I was like, let me do the PhD and also get more knowledge on how to set up. Because at masters I've done the space-based observation. So like they told me, if you want to learn how to do the ground-based observation, it's better you do PhD so that you can cover a big project, a bigger project. So that's how like I got PhD. Yeah. So, but there are so many opportunities. There are government scholarships, which is CSC. If you put in CSC in your what? In your search engine, maybe I'll send the links to people. I don't know who your coordinator is. The CSC, that is government scholarships for Chinese government scholarship. So they have CSC, then they have school-based scholarship and provincial and for other organizations. So me, I'm part of like school-based scholarships, but it's also a very good one because they sponsor you tuition, where to stay, and give you some little stipend to feed yourself. Yes.
Yeah. All right. Thank you. I think maybe you can share with me that information and then I'll share with the rest of the colleagues. Otherwise, thank you very much. Let's give a big hand. Thank you, colleagues. Please next week.